Good afternoon, everyone. I hope you are all safe where you are. So I would like to welcome you to this very interactive panel about industrial decarbonization. It's a great pleasure to join a UT Energy Week and speak about a topic which is very relevant to all of us and close to my heart, which is about how can we help the climate change and take urgent action to really meet the Paris commitment to keep the rise of the global temperature to well below 2 Celsius compared to the pre-industrial levels. And today I'm going to be joined by two esteemed world leaders in the topic. And we're going to be having like a panel to discuss the why, the what, and the how, and how can we all collaborate together to make a difference. First of all, I would like to introduce myself. I am Marwa Al-Ansary. I am the General Manager of Long Range Research and Experimentation at Shell. I had the pleasure to work in many countries through the past 25 years of my career. I worked in Egypt, the UK, the Netherlands, India, Qatar, and Australia. And my area of expertise was in two particular areas, which is decarbonization and sustainability. And now I would like to introduce our panelists for today. The first one is Professor Brian Korgel. He is the director of the University of Texas as Austin Energy Institute. He is also Rashid Engineering Regent Chair Professor in Chemical Engineering. And he directs the Industry University Collaborative Research Center for a solar-powered future. And he has an amazing, extensive experience in academia in a lot of countries like Spain, France, Beijing, China, as well as Portugal and the US, of course. He has given more than 260 talks, published more than 280 papers. And what impressed me a lot is he's very diverse experience. He's an artist, he's an entrepreneur, he's a scientist, he's a collaborator, and absolutely he's a world leader. He wants to make a difference in the field of decarbonization and make the world a better world indeed. Hello, hi, how are you today, Brian?
Oh, great. Thanks, Marwa, for that introduction. I'm really looking forward to it. And thanks also for moderating the panel, and really appreciate it.
It's my pleasure. I'm joining you from Brisbane, the east coast of Australia today. In case you are wondering where I am actually joining you from. And I would like also to introduce another impressive world leader, which is our second panelist, Todd Brady. Hello, hi, Todd.
Hi, Marwa. Thank you.
Hello, Todd. He's the Vice President of Global Public Affairs and Sustainability for Intel Corporation. He leads state and local government affairs, media, community relations, and sustainability. He covered all the continents. He worked across the US or the Americas, Latin America, the Middle East, Asia. I think you have covered the whole world, Todd, in your experience, which is amazing. Todd is supporting a lot of global initiatives to make Intel smart and green by leading a lot of corporate-wide sustainability programs such as climate, energy, and water conservation, green design, and the integration of Internet of Things. A lot of things, to be honest. During his 20 plus years in Intel, he has represented the company publicly in enormous forums. He supported a lot of initiatives, especially in advocacy and policy. He also authored more than 20 papers in scientific journals and conferences in a variety of sustainability topics. And also in 2009, he was named by the Scientific American as one of the 10 outstanding leaders involved in research, business, and policy. So advance science and technology. Todd's background is a chemical engineering with master's in environment engineering. I would like to welcome you, Todd, to the panel today. How are you?
Thank you, Marwa. Wow, the introductions, you've built this up. I hope Brian and I can live up to the expectations, but we're honored to be here on the panel with you.
Absolutely, absolutely. And perhaps before we start, we'd like to introduce the topic a bit. We understand climate change is real. We have scientific evidence. We need to cooperate. We're having academia, we're having industry, we're having policymakers, government, everyone has to join force. But before that, maybe to introduce what industrial decarbonization means for each of you, so that the audience here can actually understand what it means for us. So maybe I can start with Brian. How can you define industrial decarbonization?
Yeah, I mean, so Department of Energy also defines it. It's essentially, if you look at the emissions by sector, it's broken up in transportation, buildings, and people generally, and industry. And so about 25 to 30% of all greenhouse gas emissions are from industrial sources. So if you start thinking seriously about a net zero carbon emissions future, you have to reduce the emissions, greenhouse gas emissions from industry. And there's some significant challenges related to that, which I guess we'll get into in the panel. But industry defined as manufacturing, for example, and we'll talk more about that.
Awesome. Thank you so much, Brian. Todd.
Yeah, I would just add, I think Brian summarized it well. When you look at each sector, there are unique challenges associated with removing the carbon. And I think the industrial sector has some very, very unique challenges just in the way that we manufacture, we create, we build, and not to disparage other industries, but it's very different to say, hey, I'm going to be carbon neutral if I'm a financial institution whose primary carbon footprint is maybe the use of electricity coming into their offices, versus the industrial sector, which likely has a number of different processed chemicals, which are greenhouse gases, processed gases, use of natural gas for a variety of different mechanisms, whether that's heating, whether that's electricity on site, whether that's running of abatement equipment. And then, of course, the extremely large, typically electrical load associated with the manufacturing process as well. And then you start to go up and downstream of the industrial sector and look at the supply chain, or look at how the product is being used, and the decarbonization of that entire value chain becomes extremely complex. So we've got our work cut out for us as an industrial sector. I think we're all committed to how do we get to a carbon-free future, but it's quite a challenge for the big manufacturers and industrial producers that are out there. So great topic to discuss today.
Absolutely, is a great topic, and also one of the hard facts or dilemmas we're having, we know the population will be increasing by almost a third by 2030. People need more energy, and we know even if we do all the energy efficiency, we need like more than 30% energy supply because of the demand. And the challenge is we're talking about the net zero emission or decarbonization. So really we're having a big challenge. So I would like to start with the why. Like from your perspective, why it's the big deal, especially to focus today in this panel on industrial decarbonization? Because I mean, like we can do a lot of other things. Why in specific, this is a focus area for today? Perhaps I can start with Brian.
Yeah, well, I mean, one of the reasons that I'm personally very interested in it is because if you think about, I mean, people spend a lot of time thinking about the other sectors in terms of decarbonization quite a bit. I mean, transportation is one that's on everybody's minds. Yet, again, industrial decarbonization is really, really important. And some of the most difficult sectors to decarbonize are industrial sectors. And some of that has to do with, for example, making certain materials like steel or cement that inherently produce CO2. So if you start thinking about reducing carbon emissions, it's not just about the energy, maybe the heat source, but actually the material making itself is is related to the emissions. And so I think that's why we have a special panel on industrial decarbonization, is because it's so challenging. And as Todd mentioned, every different manufacturing sector has different challenges or unique challenges. There are some manufacturing sectors that require very, very high heat, high thermal processes. Other sectors like snack making have very large carbon footprints, but don't use the same sort of temperatures, have different kinds of challenges. And so I think it's this multifaceted aspect of the fact that we're talking about multiple different kinds of industries. Some are extremely difficult to figure out how to do carbon abatement. So that's why we have a whole panel on this topic.
Yeah, and if I could chime in, I think Brian's done a great job of outlining the challenges. I think I'd start with the why from my vantage point being this is the most significant environmental challenge that we face as society. So we've all got to get on board, whether we're in the industrial sector, the commercial sector, the transportation sector, the agricultural sector. We've all got to work together and figure this out. And we're all connected typically throughout our value chain, our supply chain, up and down. And so I think the exciting thing for me, being an environmental professional and having worked in the field for several decades now, is that this is a front page topic now. We're all coming together and saying, yep, we got to do something about it. That wasn't the case 20 years ago. And so it's great to see everybody rallying around that. So from a why standpoint, that first. And then I'll just share from my vantage point some of the other drivers behind it, in addition to what Brian said. When we look at our customers, so Intel is one of the world's largest semiconductor manufacturers. We make a product that then gets incorporated into our customers, whether that's a server, a notebook computer, desktop computer, networking device, whatever that is. They want to decarbonize their product and their supply chain. And so they're turning to us and saying, Intel, what can you do to reduce the carbon footprint of the product that you're providing to us? And similarly, we're turning to our suppliers, whether that's a raw material supplier or a industrial gas supplier, or you name it. And we're asking the same thing. What can you do to reduce your carbon footprint? So we have that pressure coming in as well. And then I'd add two more. Investors, people who invest in our company, and I think most public companies also want companies to be responsible. Again, as this is a societal issue, increasingly this is a boardroom topic among investors and our boards. That is, hey, what are you doing? What are companies doing to help the world move to a net zero or carbon-free future? So we certainly see that trend as well. And then lastly, I would say for us, it's also about attracting talent and employees. And more and more, we see that employees want to work for a company, not just to earn a paycheck, but to make a difference and feel like they're working for a company that is making a difference and is committed to such critical issues, such as climate change, and doing something about it. So I think all of those factors come together, for me anyway, behind the why we should be talking about this.
Well,
That's
I'll
awesome,
also,
yeah.
So Marwa, I was just going to build on that a little bit. I mean, Todd, you're sort of getting into the whole value chain and that sort of thing. And I think there was a time period where, or at least from my perspective, it was a bit of a confrontational tone between like energy suppliers or oil companies and end users, and who should pay the carbon tax and all of that. And maybe there's still a little bit of that, but I think my sense is that industrial partners realize that everyone just needs to work together to solve the challenges, that it's not going to be solved by someone reducing, increasing their energy efficiency on the demand side, or, the oil producers or energy producers lowering their carbon footprint. It's all interlinked. And I think that's another thing that I think is really encouraging, because I see that from the industrial partners we interact with through the Energy Institute, recognizing this need to collaborate to solve these challenges, as opposed to pointing fingers at who should pay the carbon tax, I guess.
That's awesome. I would like actually to revisit one of the drivers of the why you mentioned, Todd, about attracting talents, and the question to you and to Brian: how do you see actually the change over the past maybe not even 10 years, because I think the last 5 years or the last 2 years with the COVID as well crisis, how do you find, has anything changed the pace, the demand of the new talents of specific areas they want to study or to work on?
Yeah, I'll give you my vantage point as an employer who hires thousands of new employees a year, and then I welcome Brian's thought, because he's working with the young people, the college students who are who are going to school and graduating even more than I am. But we've clearly seen an interest across the company in, hey, what are we doing about these issues? And, not just climate change, diversity, inclusion, societal issues that we're all dealing with and that we're all working on. And we have definitely, over the past decade, seen more and more interest from our employees on these topics and what's going on and what's the company doing and how are we responding. And it is not just from the environmental engineer or the chemical engineer. It's from the attorney. It's from the marketing department. It's from the finance department. And the great thing is everybody wants to get involved. One of the biggest challenges, quite honestly, that I have is people coming to me and saying, hey, Todd, what can I do to help on sustainability? I'd love to be involved. Plug me in. How can I help? I've got a finance background, or I have a marketing background. And so I think it's great that you're seeing that, I think, across a lot of companies in integrating sustainability across the company through the various disciplines. It's no longer just an engineering issue to work, but it's one that we can engage all the various disciplines across the company, and we're seeing that interest. So that's my vantage point. I'll let Brian chime in.
Yeah, I mean, I think so. I started teaching at UT in 1998. And I think over the course of my career, students' interests have sort of evolved and changed over time. And right now, students, I think more than ever, come into school, they're 18 and they already want to make a difference somehow. So last week we kicked off a Smart Energy Innovation Challenge for our undergrads across campus, and Shell's actually one of the sponsors with Chevron and another company called Affinity Engineering. And the students come to school, they're looking to make a difference. They want to do things, not just solve problem sets in the classroom and that sort of thing. And I have 3 kids. My 2 boys are a little bit older, so they're millennials. They're pretty solidly millennials. And my daughter's 18 and she's Gen Z and would never say I'm a millennial, and my boys would never say they're Gen Z either. And so I was doing, having some discussions with. So almost all of our students now are Gen Z, and so. So there's some discussion I was having last year as I was taking over at the Energy Institute with some folks about energy. What are students thinking these days? And there was some polling that was done of Gen Z students, and apparently the 2 main issues that they cared about were, first of all, COVID, which their whole Gen Z kids' lives are totally affected by COVID. And climate change. And so with those two main issues, and students coming in wanting to make a difference already, even in high school and before, they want to ensure that where they go work, first of all, is a responsible, workplace, and the people have, their society's best interests in mind, and they want to make a difference, and they want to have a positive impact on society and climate change, and trying to help solve that challenge. And so I think what students don't fully appreciate, that the decarbonization challenge is intimately linked across industries. I mean, probably if I asked, I teach materials is one of my classes that I teach, and if I asked the majority of my students, probably, you know, what role does Intel have on industrial decarbonization? Probably most of them would say none, or I'm not sure, or very little, or something like that. When the reality is Intel is just as linked in the whole challenge as much as Shell or any other company these days. And so so I think that's the thing, is students may not fully appreciate how intricately everything is linked in terms of solving the societal challenge of climate change, but they care a lot about it, for sure.
That's awesome music to my ears. I also, observe the similar, passion, not just for the younger generation, but across the board. Everyone want to participate, everyone to play a role in this. And this will be a very good segue to my next question, which is about the what. What is industrial decarbonization? And if you can tell us like some of the big themes like you're working on, or things to challenge you think we should be focusing more on in the coming, years, if not months. Maybe you can start with Todd.
Sure. Yeah. Let me start with our perspective. So maybe I'll start at a high level and kind of drill down, and we can go, whatever direction the conversation takes us. But when you talk about, your carbon footprint, for those who are familiar with this, I apologize. I'll take just a minute to kind of walk through what we call scope 1, 2, and 3. And that's kind of an accounting of how we measure our carbon emissions, our carbon footprint. And so for a company like Intel, we look at all 3 scopes. Scope 1 being our direct emissions. These, as a manufacturer, these would be things such as the gases, the chemicals that we use in the manufacturing process, the industrial processes that we have that get emitted. And those have a global warming potential, which then leads to, which is a greenhouse gas, and that gets accounted for as our scope 1 emissions. Scope 2 then would be the indirect emissions that are associated with our energy usage. So as a large energy user, if we are using power off the grid, and that power is from coal or natural gas or other fossil fuels, then there is a carbon emissions associated with that. So we have to account for that as well. And then scope 3 would be our value chain. So that would be our supply chain, the carbon footprint associated with materials that we're taking into the company. And then for us, the product that we produce, the microprocessor, consumes energy when the consumer uses it. And so that would also be part of the scope 3. And so as a company, as we look at how do we get to net zero, we're looking at all 3 of those areas, scope 1, 2, and 3. Well, let me pause there. Let me let Brian talk, and then I'm happy to go into each of those areas and talk about some of the things we're doing and where we need more help, more research and development, and those kinds of things. So, Brian, did you want to add anything?
Yeah, well, I would just say the industries that people call out, for example, are chemical manufacturing, petroleum. Those are probably 40% of the emissions from the industrial sector. And then you have steel making, significant food and beverages, cement making. Those are some of the main sources of industrial greenhouse gas emissions. So then we think about what are the strategies for decarbonization of those industries. First of all, like, where's the carbon coming from? First recognizing that, and then trying to think of alternatives, to those processes that are in place right now. Yeah, so Todd, I'd love to hear a little bit more about, from Intel's perspective, what your big challenges are.
Yeah, so I'll start kind of with each. Maybe we can walk through each kind of scope 1, 2, 3. Yeah. So in scope 1, these again are chemicals, gases that we use in the manufacturing process, as well as then natural gas, which we use for a variety of purposes. But The chemicals that we use in our manufacturing process are primarily for us, so for the semiconductor sector, the biggest greenhouse gases are what are called perfluorocarbons or perfluorocompounds. These are fluorinated chemicals. They're actually used in the semiconductor process for what we call etch, or etching the circuits into the silicon wafer. And the fluorine molecule is critical for us to be able to do that, to accomplish that. So we're now building chips that are the size of your fingernail, and they have over 1 billion transistors on them. And so we're down very much at the molecular level in building these devices. And so we need those fluorine molecules to help etch the connection between the various devices. And so to tackle that, we actually started, believe it or not, 20 years ago, and started looking at, could we replace any of those chemistries, particular gases that have a high global warming potential, and can we replace them with the gas that has a lower global warming potential? And so we began doing that back in the late 90s, early 2000s. That was the first step that we took. And then from there we said, okay, we still need to use these gases, they're critical. What can we do to abate them? And so we have a variety of different abatement technologies that we use to reduce the amount of emissions of those gases coming out of our factories. And so in that area, some of the key research that's still needed is, can we further make chemical substitutions? Are there other options that we can look at that don't have a global warming potential at all? And that's fundamental chemistry that needs to be developed. And won't happen overnight, because these are widely used across the entire industry. And then number two, can we abate those chemicals in a more environmentally friendly manner? Typically, the state-of-the-art abatement devices today use natural gas to incinerate, break apart the perfluorocarbons, which are very stable compounds. And so you need high energy to break them apart, but that also then has CO2 emissions associated with it. So what are the opportunities to come up with new novel abatement technologies that will reduce that footprint further? And then I would say the other thing in our scope 1 emissions would be the use of natural gas. And that's typically for heating applications, as well as, like I talked about, various abatement technologies. So are there alternatives to using that? We have been very successful in doing a variety of projects to capture the waste heat out of our factories. So our factories are full of what we call tools, pieces of equipment that are plugged in using electricity, generating heat. And so you dissipate that heat, and we've done a number of different projects where we can capture that heat and therefore reduce the amount of natural gas that's needed for heating. But we still need that natural gas for a variety of different abatement devices to reduce the emissions coming out of our factories. So what could be done there? So those are three areas that, as we look to academia and fundamental research, where, we can use help. And I think those are areas that aren't unique just to the semiconductor industry as well, but across multiple industries where we need novel solutions to further reduce our carbon footprint.
Excellent, excellent. Brian, would you like to add something to that, of the what, the headlines really, before we deep dive into the how and the complexity, but what is the broader things you think we should be focusing or we should be working on from academic point of view?
Yeah, well, I mean, I think my perspective might be shaped by my training, as an undergrad and a PhD. I mean, I'm a chemical engineer. I also am a nanomaterials chemist. That's basically my research field. So I have a background in materials. I teach materials. I'm a chemical engineer, so I know about processes and systems and things like that. And then I also do a lot of research on solar, and I direct a solar cell, research center, and I've been working on, that center's been around for 12 years and continues to flourish, as the solar industry continues to expand. So so in the solar area, you have new technologies that are emerging, like utility scale solar that, according to Lazard's, the cheapest form of electricity without subsidy. And so you have really inexpensive form of energy, systems challenges. How do you reconfigure a chemical plant, for example, and materials challenges in a lot of cases. And so for me, thinking about how all of that expertise can kind of converge into solving a major societal challenge, which is getting to net zero carbon emissions. I mean, that's how I think about all these things. So in almost every sector, you have challenges. People talk about low carbon fuels for like shipping, for example. So if you want to get rid of the carbon emissions from a ship transporting material, how do you do that? How do you do that sort of thing? And so there are different kinds of solutions. People talk about ammonia. Use ammonia, NH3, as a fuel for ships, and maybe you can take nitrogen with clean hydrogen, and then you're essentially burning ammonia, and people worry about NOx emissions, and then there are solutions to that challenge. So it's really fascinating to me as a scientist and a researcher, thinking about all of these different problems that involve chemistry, materials, systems, emerging technologies with really important societal goals. It's fascinating to me.
That's awesome, Brian. I'm very curious from an academic perspective, because I believe universities like UT, you are providing the talents, providing the future colleagues to us in the industry, and also people who are going to be working in the policy making, government, and others. So really, I will put a lot of emphasis on how we can nourish this. So from your perspective, what competences we'd like to start focusing on? Is this going to change the way we're putting our curriculum or courses? Is there any shift between what we used to teach maybe 10 years ago and what we're teaching now, and what we would like to teach in the future as well?
Well, I mean, I think another thing that shifted over the course of my academic career is how we educate our students. I mean, the students, they want to do more than, again, just like, I'm a card-carrying chemical engineer. This is how chemical engineers have been trained since 1960. I want the exact same training. I mean, I think we still drill the fundamentals into our students. They have to be able to understand, as a chemical engineer anyway, mass balances and energy balances and that sort of thing. And those fundamentals don't change. But I think where we've done a much better job institutionally and continue to work towards it is trying to give students more kind of interdisciplinary, collaborative experiences in their classroom. So I teach a Maymester, a study abroad class that's called Nanotechnology Innovation. And in that class, it's a semester compressed into a month. The study abroad, so it introduces students to global, what's it like to kind of live and work in a global environment. And that class is all about taking students I usually have students from 8 to 10 different engineering majors across campus, radio, television, and film, sociology. I mean, it's basically anyone who's interested in entrepreneurship and nanotechnology for beginners, basically in a global setting. And so just having the chance to put all these students together to work on problems that they're interested in. I mean, that's another thing that we do in that class is I ask them, okay, if we think about a problem like urban sustainability, or maybe it'd be industrial decarbonization, what are the challenges that you see, and ask them to think about the questions. And so I think those factors, like, we rarely ask students to come up with the challenges themselves. Like, what do you care about? I think that's changing a bit in academia, trying to get students to recognize that what they care about is important. Ask them about that, get them to work and be comfortable with communicating with other students in different disciplines. So deep knowledge and expertise in an area, but having the ability to work together on teams and communicate across disciplines. And I think we need to do that a bit better, still, but I think that's what we're moving towards as a university. And the topic, another buzzwords, experiential learning, trying to get students, taking what they're learning in the classroom, try to apply it to the world as well. So again, I mean, the topic of industrial decarbonization is kind of an ideal one for helping train students with that interdisciplinary mindset and thinking about a big problem, breaking it down into pieces, and having to work with other people where they, each one of them knows a lot about their thing, but they don't know much about the other stuff that the person knows about, So I think that's the way I think university education is moving more towards. Because if it's just knowledge, students can go online and, read Wikipedia and do all that stuff. We didn't have that when I was a student, which I wish we had. But, so knowledge acquisition, I think these days is really easy for students almost. What's difficult is how do you get them to, how do you create experiences for them where they can work together? Yeah.
That's, if I could add on to that, that's a great example. And earlier I talked about some kind of fundamental research that we need, and that's critical as well. But it's easy then to kind of put our head down, get in our silo, and focus on that, when some of the biggest breakthroughs come from pulling people with all sorts of different backgrounds and disciplines together. And let me just give you, and so this kind of shifts from, at least from our vantage point, from the threat to the opportunity, which is one of the opportunities in the decarbonization space, from our vantage point, is digitalization. So using technology to help others reduce their carbon footprint. And I'll give you an example of some things we've done at Intel. The last two big buildings that we built, one was in India, one was in Israel. We pulled together a team of engineers, but not just engineers, planners, those who were interacting with our employees and what they needed and stuff, and said, okay, how do we design these buildings from the ground up to be more environmentally friendly and more engaging for our employees, that it's a place they want to come to. And the result, I won't go into all the details, but the result of all those were a couple of LEED Platinum buildings that use, a third less energy, significantly less carbon footprint, about half as much water, incorporate all sorts of renewable energy, fuel cells, as well as smart technologies that are all integrated in monitoring the building real time to optimize the use of the air conditioning and the lighting and all of that, as well as deliver a better experience for the employee. So making things available for the employees where everything's tied together. They can order from the cafeteria on their smartphone and have it delivered to their desk. Or these are just examples. We locate the building near mass transportation, so it makes it very easy for employees to go back and forth to work. And so having all those various inputs helps us to think about things more holistically and come up with a solution that starts checking a lot of boxes, including reducing that carbon footprint.
Awesome. So I would like to go to my last question, and you have actually answered a lot of the items on the how. How complex is the challenge? Especially, you mentioned both of you very important elements is about, it's not just about the carbon footprint, but it's about the overall sustainability elements, is a circularity, how we are actually dealing with the land footprint, with the waste footprint, the water usage, and so forth. But how do you feel about the base? Because I know everyone is doing their part. I know some of our stakeholders, they are not happy with the base we're actually delivering. So why and how we can actually fasten, how can we accelerate the rate of the decarbonization? What is the challenge and how we can do that? Who who would like to take
Well,
this
I
question
mean,
first?
I'll
Go
just
ahead.
start by saying, what one of the things I think makes industrial decarbonization super challenging is that you have industries that have been built up over time and just optimize their processes and where they get their energy and how they do things, to to make things at scale that are incredible and extremely low cost. And now you're asking a chemical plant that makes ethylene to almost completely change their energy source. For example, if you electrify that, it doesn't make sense to electrify a power plant from natural gas produced electricity. You lose 65% of the energy when you convert the natural gas into electricity, just because of thermodynamics. So if you're going to electrify your power plant, where do you get the electricity? So does a chemical plant now need to install a pretty large solar farm right next to it, so it becomes a different kind of energy producing entity? And then if you're using solar's intermittent, so how do you deal with intermittency with a chemical plant? If you need to get to high temperature, how do you take electricity and get to a high temperature and do all that cost effectively? And then what do? You retrofit the plant, or do you just build new plants, right? And that takes a lot of capital. So you've got financial challenges. Where does the capital come from? You've got, people's jobs. What does the plant shut down? Can they still make money? All of those sorts of things. So these are major challenges, where you're talking about taking huge factories and trying to change the way that they do business. I mean, I think that's what makes it one thing that makes it really challenging. Not to mention there's certain things that we actually don't know how to do, like completely decarbonizing cement making and things like that. So that's another aspect.
Yeah,
So
those are great examples. In fact, Marwa, if I can add, a few thoughts. Again, if I go back to scope 1, 2, 3. So scope 1, doing some of the things I talked about earlier, making the chemistry changes, putting abatement in place, energy efficiency activities in our buildings and our factories and whatnot. We've been able to reduce our carbon footprint by about a third while growing our manufacturing capacity 3x. So kind of decoupling the growth from the carbon emissions. And on a per product or per chip basis, that's like a 75% plus reduction. So we've made a lot of progress, but now it gets harder and harder. As Brian was saying, what's left becomes a bigger and bigger challenge. And so, we've got work to do there, and we need to partner and work with our suppliers and others to make that happen. The second thing from our vantage point is investment in renewable energy. We're a big energy user as well. So we believe we have a goal to be 100% renewable energy by 2030 globally. We're about 80% plus today. And we believe that sends a signal to the market that there's a demand there. So we're investing wherever we operate, we're investing in renewable energy. We want to send a signal to the market to say we need more, we want more. And there's challenges there because that doesn't happen overnight. The sun doesn't shine at night. And so, we need these transition technologies, right? The wind doesn't always blow. And so we need the transition technologies to help get us there to 100% renewable energy. And then the third thing I would say is, again, back to everything's becoming digital. Huge opportunity. That there was a study out of Europe by a group called GESI, the telecommunications sector. And their conclusion was that for every ton of carbon embedded or emitted by the IT sector, one had the opportunity, if you were to apply the technology to the agricultural sector, the commercial sectors and whatnot, to save up to 10 tons of carbon for every ton of carbon that you invest. So a 10 to 1 return. But we need to identify those opportunities. And I just noticed there was a question in the chat about Bitcoin, Bitcoin and cryptocurrency and all the energy that's used to produce cryptocurrency. And so interestingly, one of the products that we just announced is a new processor that we believe is about 1,000 times more efficient at mining that cryptocurrency. So, as we look at where the technology is headed, as a company, we're trying to get ahead of that and say, okay, what can we do? What can we change about our product design to make it more energy efficient and to reduce that carbon footprint? And we have a responsibility there to continue to innovate and make the data center more energy efficient, make your laptop more energy efficient, make the crypto mining more efficient. And so tremendous opportunity, I think, as we go forward.
Fantastic, fantastic. I really like your points, because the challenge is big. It's not because we don't want to actually to move fast or accelerate the energy transition or the decarbonization. It just, we need the effort of everyone. I think we need a collaboration between the academia, between the industry, between the NGOs, between the regulator, the policymaker, investors. I think we need everything. And I truly believe one of the routes to deliver this is by innovation. And I'm very, very happy to be joining this panel to have innovation from UT Austin as well as Intel. We have some questions as well, and one of the questions is about historical cumulative burden of emissions. So it's not about what we're going to be emitting, but what happened. We have a lot of accumulation of this kind of emissions. What we can do about that?
Well, I think about that a lot. I mean, if you really are serious about thinking about a future with net zero carbon emissions, I think you have to address historical emissions. I think in terms of what motivates people, I mean, for better or for worse, I think a lot of it's financial and down to money. The panel before this is super interesting on the direct air capture and those technologies. I think for things like that to take off to the next level, there needs to be, something. I think if you can figure out how to take CO2 from the air and create products from it, and high value products maybe, or just products everybody needs, but you do it at scale, then you will solve the problem. I mean, people will create businesses, you'll have people doing that stuff. I think that's a challenge. CO2 is a really stable molecule. It's a very, very low concentration in the air. So how do you do that sort of thing? But people are coming up with really creative solutions. There's a kind of a startup company that I always like to tell my students about, because their mind is blown, which is this company that takes CO2 out of the air and makes vodka out of it. And all the students are like, wow, that's amazing. I mean, they do a really small scale, and I mean, how much vodka can you sell and stuff like that. If you could take CO2 out of the air and directly convert that to cement or do something like that, then you would solve the climate problem. But I think that's some of the challenge. How do you address historical emissions when CO2 is a very stable molecule, very, very dilute in the atmosphere?
Yeah, I think I agree with you, Brian. We call it kind of a portfolio approach. There's not just one solution, right? You have to have a portfolio of solutions. We came to that realization early on when we set this goal of 100% renewable energy. We quickly realized, even though we went and installed a bunch of solar panels and invested in on-site renewable energy solutions across I think about 100 different locations, that was a fraction of the energy we needed. There wasn't enough room to put solar panels to, power one of our big industrial fabs. And so you go, okay, that's only one piece. Okay, well, what else can we do? Well, okay, let's go partner with utilities to say, can we invest in utility scale, or can we sign a contract with you while you're investing in it? Can we, buy renewable energy credits, which the wind turbines may be in another state, but at least we're sending a market signal that it's important and there needs to be more investment. So in all of these, you need this portfolio type approach to get to the solution. There's not a single, magic bullet, silver bullet that's going to get us there. we've got to have a wide variety of different
Oh,
solutions.
yeah. Absolutely. It will not going to be one size fits all. So it has to be an equation with a lot of variables. And we need to, like address a number of things, from energy efficiency to the integration to renewables, to technologies, to new molecules, to capturing CO2 from the air, creating dense energy carriers, and so forth. But there is other things as well, which is about carbon offset. You spoke about renewable energies, the RECs, renewable energy certificates, but what about the carbon offsets? What is the view of Intel on purchasing carbon offsets as part of the equation of the portfolio options for managing carbon challenge?
Yeah, we haven't done that yet. We haven't purchased any carbon offsets. Our kind of fundamentally, our focus is, hey, let's first try to reduce as much as we can ourselves before we go and buy offsets. Now, that's not to say that offsets don't have a place. Again, it kind of goes back to that portfolio. I suspect that as we continue to go down to this path to get to a true zero, at some point, we will probably have to buy offsets. We're not there yet, but at some point we may need to do that. And so I think the work in the offset area, I think, is to make sure they're credible, quite frankly.
Yes.
And so to make sure we have good mechanisms that when one does invest in offsets, that they're quantifiable, they're credible, and that they are achieving the purposes, that they're set out to do. So anyway, that's our view on offsets.
What about you, Brian? Do you work in the area of carbon offsets, or the university working on this? Because you work on solar renewables. What about nature-based solutions in general?
Yeah, I mean, I don't think that much about carbon offsets myself. It's a little bit away from what I do, but we certainly have faculty who think a lot about carbon offsets. And think about policy, trade-offs and things like that. I guess from my perspective, maybe because I'm an engineer and kind of technology focused, I personally feel like companies that are making net zero carbon commitments, it's not really appropriate to just hang their hat on carbon offsets and things like that without pitching in and helping figure out the actual technologies that are going to make it happen. So.
Absolutely. It's, as I said, it's a lot of things we have to do. It's not just one solution. We have to focus, and we need all the collaborative effort. No one can do it alone. Hence, it is amazing. The more consortium and collaboration we can do together, the better we can actually accelerate into the energy transition and decarbonization pathways. I have a question, and I'm very happy when we receive questions, because it means like the audience are very interactive and engaged, and they're really excited, but I'm not sure, who can actually answer this question. And it is about nuclear energy. What is, like the aspects of the non-sustainability of nuclear energy in terms of the waste disposal, the lifetime embodied energy to be considered? Any comment on the context? How can we use nuclear as one of the parameters for decarbonization? So is it in or out?
That's a great question. I'm going to defer that one to Brian. I'm not a nuclear energy. I'm not a nuclear energy expert, but hopefully he knows more about it than I do.
Yeah, I mean, I think like it's one of those things where I don't think we want to just take technologies off the table, and nuclear is obviously really important, and depending on which country you're in, you have more or less nuclear. I mean, the big challenge with nuclear is nuclear waste. Once you make it, you have at least 10,000 years of storage. I mean, it's almost unfathomable to think of the time scales from a human perspective, and probably closer to 100,000 years that you have to store this stuff somewhere. And nobody wants it, and if you talk about not in my backyard, I think nuclear waste is going to be at the top of not in my backyard, right? So I think that's the challenge. I mean, not to mention, I think some of the security issues and things related to nuclear, and where some of the countries that really need the energy the most probably are maybe some of the least safe places to put nuclear. So I think those are some of the challenges, security, the waste, and so it's a really important energy source, but those are the big challenges with it.
I will ask that question not about nuclear, but about wind and solar. You mentioned about this one. From a sustainability point of view, what is the challenge to use this source of renewable, not from a technical challenge like Todd said about the energy storage and address the intermittency, but the impact on the environment?
So I think about that a lot from a solar power perspective, because in the last 10 years, if you looked at how much electricity was generated from solar 10 years ago, it wasn't even on the map. It was like less than 0.1%. And last May, I think it was up to 5%. In order to get that kind of electricity generation, it requires land. And even if you're putting massive solar farms out into the desert, which people think, oh, it's uninhabitable and everything. I mean, those are still habitats, and there's biodiversity out there. And so I think there's a lot of development happening related to, renewables in the habitat, how it affects diversity, biodiversity. People are developing new technologies like agrivoltaics, where you can actually have solar plus food production, for example, in the same location. So these are things that I don't think should be swept under the rug, that I think as academic institutions, we need to appreciate. Yeah, you put in, 4 gigawatts somewhere of solar, that's a lot of land, and making sure you understand what the impacts of that are, even if it's in the desert, is really, really important.
Awesome. So I would like to ask you for your final thoughts, but also there is a question, final question, if you can incorporate it in your final thoughts. It is about last night, President Biden mentioned in his State of Union address to incorporate new technologies to reduce its emissions. So in your final thoughts, how you think, like the way forward, and how can you utilize this perhaps as an opportunity to speed up, especially from a finance perspective, some of our technologies. So please, your closing remarks, please, Brian or Todd.
I'll just say really quickly. I mean, I'm thinking a lot about the UT, University of Texas perspective. What can we do with industrial decarbonization? And I think, we've got things going on in clean hydrogen, for example. We've got one of the DOE H2 at scale projects here, and so thinking about how you bring all these things together, hydrogen plus CO2 capture and storage, and solar and wind, and how do we integrate the demand-sided innovation and everything. I think it's a really exciting time for energy. Major challenges, but I mean, for students, it's an amazing time to do some research and learning in energy as a field, I think.
Thank you so much, Brian. Todd?
Yeah, and if I would just add, President Biden last night referred to our investment in Ohio, where we're going to be building new fabs. And our commitment there aligns with what we're doing other places in the world, which is 100% renewable energy. And so we've begun to engage in that state with the utilities to say, how can we do that for our Intel factories? And that will require some innovation, some additional investments, and we're excited to see where that goes in terms of how to spur further investment in renewables in Ohio. The second piece of that commitment is what we call 100% or water positive. So for every gallon of water that we take into our operations, we want to return a gallon or more back to the local streams, rivers, aquifers. And so that's going to require investment in a state-of-the-art water reclaim facility where we're using water over and over and over again. And so again, that's under design, and we're in the process of working on that. And then the third commitment that we've said is we want to be zero waste to landfill. And so again, new technologies to how do we minimize our waste? How do we capture, recycle, reuse those wastes over and over and over again? So if I could leave a thought with the students, it would be, this is just a phenomenal field. It really is, to just see how much sustainability is exploding and the opportunities. And we need great minds, forward thinkers. People can think out of the box, do things differently to solve the challenges that are in front of us. And it's really an exciting area to be in.
Thank you so much, Todd. We are on the time, and I would like to leave the audience with one thought. What will going to be your role in the energy transition and the industrial decarbonization, or the grand challenge of climate change? We need you. We need innovation. So please, think about and reflect. So I would like to close this panel by thanking Brian and Todd and the audience. And please stay safe and happy. And stay also online, because we are having a very amazing session coming, which is finance of emerging energy startups. So please stay tuned and online and be happy. Cheers. Bye-bye.
Thank you, Marwa. Thanks, Todd.
Thanks, Marwa.